Right, now let's look into the limiting reaction examples. Say, for example, we have 4 glasses, we have 5 liters of water and 3 liters of Oris, and you make maybe juice for your friends, okay? So you take the glass, water, and Oris, zoop. Then you get 1 glass of Oris, then you make the next one, zoop. Then you get another glass of Oris, the third one, zoop. Then you got the third glass of Oris and the last one, zoop. And then you are out of Oris. So therefore now, because if you can see, you got 3 glasses of Oris but 1 glass of water. So therefore Oris is there what now? As the limiting reactant or the limiting ingredient. And water is the excess. What? An excess reactant or excess ingredient. So now what is a limiting reactant? It is the first reactant that is used up in a reaction. Okay, so Oris got used up first in the reaction, and the excess reactant is that is left over after the reactant stops or after the reaction stops. So because of the limiting reactant got used up. All right, now let's look into a real chemical example. The question says, how many grams of NH3 will be produced if 14.32 grams of N2 reacts with 4.21 grams of H2? All right, so firstly you need to write that in a formula, okay? Then you need to balance it. You can see we have 2 nitrogens this side, therefore we also need 2 that side. You put that there, and then because of we have 6 this side of hydrogens, we're gonna need 6 this side, so we're gonna put 3, and our equation is balanced. All right, so the second step, you write down what is given and what is needed as a symbol. So this is what is given. Actually, let me put this here so that you don't get confused along the way. So you've got 14.32 grams of this, 4.21 grams of that, and this is what we want. Okay, so we put a symbol, any symbol that you prefer, so I prefer that one. All right, and then the third step, that's where now you convert the number, this grams, to a number of moles. So you know that for a number of moles, you use this grams times the molar, or divided by the molar mass, it will give you the moles. All right, you do that for nitrogen and also for hydrogen. Okay, so the fourth step, that's where now you use the conversion factor ratio or formula. That's for the first one, we check how many moles of hydrogen do we need to use all the moles of nitrogen. Okay, so we know that from step 3 that nitrogen has 0.511729849 moles, and then we can see from here on our first step that the moles of nitrogen in the reaction was 1 mole, okay, and those of hydrogen were 3 moles. All right, so the method you're going to apply, you say 3 all right, so I was saying the method you're going to apply, you say this number of moles times that 3 divided by 1, it gives you this. Okay, so therefore to use all the moles of nitrogen, we need 1.5335189555 moles of hydrogen. From step 3, do we have those amount of moles of hydrogen? Yes, we do, because we have 2.0 something something something. And then you come to hydrogen. For hydrogen, we saw that we have 2.08889 and so forth moles of hydrogen, and then we had 1 mole of nitrogen from there, and then 3 moles of hydrogen from there. Okay, and then still the same method, 2.088 times that 1 divided by this 3, it gives you the 0.6960978833 moles of nitrogen. So to use all the moles of hydrogen, we need 0.6960978833 moles of nitrogen. Do we have that? No, we don't. So therefore, nitrogen is the limiting reactant. Okay, so for the final number of moles, For nitrogen, you still use them, the initial ones, because of it is the limiting reactant. And then for hydrogen, you say these number of moles times that 3 that you got there, and it gives you this. You still calculate it there, so you can just drop it there. And then for NH3, you say these number of moles times that 2 that you got there, and it gives you this. And then that comes to right. So for step 5, you take the number of moles of nitrogen, of hydrogen, and NH3 to get the grams. All right. And then after that, you add these grams, and then you get that, and then you check is the left hand side equal the right hand side, and it is equal. Though you can see that this is the last digit is 1 there, and here is 2. In most cases, the last digit is not the same, but in some cases it is the same, so it is still fine. Thank you.